Okay, let's dive into this because, well, everywhere you look right now, people are talking about AI agents. But if we're being completely honest with ourselves, almost nobody is actually explaining what they are or how you build them. AI agents are suddenly everywhere. Every tech company seems to be talking about them, and sometimes the explanations make them sound almost like digital employees that can think for themselves and just go off and get things done. But when I started looking into how they actually work, I realized they're not nearly as mysterious as they sound. In fact, when you first open an AI agent, it may look exactly like a regular chatbot. You get the same blank box, type something in, and get a response. The big difference is what happens after that response. But underneath all that hype, the technology is actually a lot easier to understand than it sounds. And I think part of the confusion comes from the fact that an AI agent and a regular chatbot can look almost exactly the same. You open either one and basically see a blank text box. A standard chatbot does something pretty simple. You type a message, it uses what it learned during training along with the information you gave it to generate a response. Then that interaction basically stops until you give it something else. An AI agent starts with that same basic technology, but gives it the ability to take outside actions and repeat the process. It takes an action, looks at what happened, decides what to do next, and keeps going until it either completes the goal or reaches some stopping point. At the center of every agent is still the large language model, or LLM. People often call this the brain of the agent. That's a useful way to think about it, but the brain by itself is pretty helpless. The LLM is basically isolated from the outside world. It doesn't have hands, it can't physically click your mouse, type on your keyboard, search the internet, open an application, or change something in a database on its own. At its core, it's still processing information and predicting what should come next. So if we want it to interact with the outside world, we have to give it something like hands. That's where tool calling comes in. Tool calling basically tells the model which outside software and services it's allowed to use. Let's say the model determines that it needs to search the web. Instead of somehow browsing the internet itself, it generates a structured request telling the host system which tool it wants to use and what it wants that tool to do. The host system recognizes that request, temporarily pauses the model, performs the web search, and then sends the results back to the model. Now, the LLM can read those results, decide what they mean, and determine what should happen next. That tool calling process is basically the mechanical bridge between an AI that can only generate information and an AI that can actually interact with real-world software. But if an agent is going to perform several actions in a continuous loop, there's another obvious problem. It has to remember what it just did. That's where the context window comes in. Think of the context window as the model's short-term memory. It can contain the immediate conversation, its instructions, recent tool calls, results, and other information it needs for the task it's currently working on. For immediate tasks, that works very well, but context windows have limits. You can't just keep dumping unlimited amounts of information into them. Eventually, you reach the model's capacity, and the system has to decide what information actually needs to remain available. That's where long-term memory becomes important. One way to handle that is with a vector database. Think of it as a huge external filing cabinet that exists outside the model's short-term memory. It can contain documents, records, facts, and other information that the agent might eventually need. Instead of loading that entire filing cabinet into the context window, the system searches it and retrieves only the information that's relevant to the current task. This is part of what's known as retrieval augmented generation, or RAG. The agent searches through that outside information, finds the pieces that matter, and brings those specific facts into its short-term context at the moment they're needed. So you're combining immediate working memory with a much larger external source of information. Connecting those memory systems to the tool calling loop helps the agent keep track of what it's doing, maintain context, and reduce the chances of losing its place or simply making something up. And that's how you start getting sustained, context-aware action instead of just individual chatbot responses. Once you connect the brain, the hands, and the memory, the agent can operate in several different ways depending on the job. The first is a sequential pattern. This is basically a step-by-step assembly line. Do step 1, then step 2, then step 3. It's useful when the task is predictable and you already know the order in which everything needs to happen. The second is a reactive pattern. This is more flexible. Instead of following one rigid long term plan, the agent looks at the current situation, takes an action, observes the result, and then decides which tool or action makes sense next. It's reacting to what it discovers as it goes. Then you have the planning pattern. This is better suited for more complicated goals. Before immediately jumping into the task, the agent first creates a multi-step plan for how it's going to accomplish the larger objective. It then starts executing those steps while adjusting the plan if something changes or doesn't work as expected. So when an agent appears intelligent, it isn't because some spark of consciousness suddenly appeared inside the computer. A lot of what looks like intelligence comes from the operational pattern being used and how the system has been designed to approach the job. And that brings up something I think gets overlooked in a lot of discussions about AI agents. The technology matters, but so does the human designed workflow behind it. You can think of advanced agent operation as having three basic pillars. First, you have the workflow. That's essentially the plain English recipe explaining how the work should be done. Second, you have the agent. That's the reasoning engine making decisions within that workflow. And third, you have the tools. Those are the actual capabilities the agent can use to get the work done. People sometimes assume the secret is finding the most complicated AI model or loading the system with a bunch of sophisticated plugins, but a clearly designed workflow using relatively basic tools can often outperform a much more complicated system built around vague instructions. And there are now different levels for actually building these systems. You can think of it almost like a builder's ladder. At the easiest level, there are visual no-code platforms where you can drag and drop different logic blocks and connect them together. You can visually define what happens first, what happens next, and what should happen under different conditions. Further down that ladder, you can work with more advanced visual logic systems that give you greater control over how all the pieces connect. And at the bottom, you can write the underlying code yourself. That gives you much more control, but it obviously requires more technical knowledge. The important point is that you no longer necessarily have to be a software engineer to start building useful agents. If you can clearly map out a logical process, there are increasingly tools that can help you turn that process into an automated system. And when you start scaling this up, you move beyond using an agent for one isolated task. You can begin creating something closer to an AI operating system. Instead of having one agent doing one thing, you can have interconnected agents handling different parts of a much larger workflow in the background. You might centralize information that currently sits across different parts of your business and then use webhooks to trigger agents when something happens. For example, a customer application comes in. That event triggers an agent. The agent researches the customer, looks at the available information, determines whether that person or company qualifies, and drafts an email response. That can happen without somebody manually opening several websites, copying information between applications, doing the research, and writing the same basic response every time. And that's where the real usefulness of these systems starts becoming clearer. Their effectiveness doesn't simply come from having a powerful AI model. It comes from how the work itself has been structured. Once you understand the mechanics, the model, the tools, the memory, the behavioral pattern, and the workflow, AI agents become much less mysterious. And then the most useful question isn't whether AI agents are going to change everything. It's much more practical. Look at the repetitive things you're already doing manually. What task do you keep doing over and over again that follows roughly the same process? Because that's probably the first task you should consider handing over to an AI agent.